So good afternoon and welcome after lunch. So since yesterday we have been talking about electrification, mobility, and the challenges and opportunities which are coming with that, right? And there are some challenges with some of the applications, especially coming from the needs of materials which are required for several applications in electrification and mobility. So this is what we are going to discuss today now. So a little bit about my company, about Royal DSM. So DSM is a global purpose-led and science-based company which is specialized in nutrition, health and sustainable living. And the engineering materials part which I am representing over here is from the sustainable living. And our purpose is to create brighter lives for all. So that's our purpose. We are with a purpose to make a brighter living for generations today and generations to come. Now looking at the bright science in the advanced materials which we are working with is in the sector of automotive, electronics, electrical and food packaging. These are our core. Then if you look at the additional focal areas which are renewable energy, consumer goods, building construction, industrial equipment, transportation and medical. So it's a vast industry which we are serving with the solutions which we have from the materials perspective. Now if you talk about the key trends in electrification and mobility, so our industry has not seen the changes ever before the way we are seeing it right now. Let it be from the technological perspective, whether it is electrification, connectivity, ADAS, or whether it is coming from the social, urbanization is one of that, shared mobility is another one, or if you look at sustainability. And all these factors are driving towards electric vehicle from fossil resource power, which we have been talking about since yesterday, human driven to autonomous, as well as sustainability is no more a differentiator. It's a qualifier for us, a strong qualifier. This is what industry is talking about. Now, where do we come? If you talk about the material requirements, the needs which are there for the EV, if you talk about the battery management, then the heat generation is going up around the battery, right? Then need for thermal management is there. If you talk about the integrated electronics, then electromagnetic interference is strong, and that's where we need EMI shielding. And if you talk about distance or the range, then we need lightweighting. The vehicle, the lighter it is, of course the range also will get. Of course battery and efficiency is also another part, but this is one of the drivers here as well. And that's where DSM comes. What our purpose is to make EVs or vehicles safer, lighter and more sustainable. So also today when I'm going to talk about, these are the three drivers, these are the three goals which we are working towards to help the industry to make vehicles safer, lighter and more sustainable. Now when anybody in the industry who knows us, when they say that okay, DSM is the material provider. So what we do is we sell the granules and everybody says that you are the material supplier. But we are not just the material supplier, we are solution providers to the industry. We are innovators who bring technologies in the market which can make those materials which are required for those applications. Yeah? So when we are moving from ICE to EV or green mobility, then if you talk about thermal management, safer thermal management systems. Now, if you want to make those safer thermal management systems, the materials which are required to make with this technology, that is what we are innovating. Similarly, if it is fuel cells, FACRA connectors, HSD connectors, ADAS, low cost and effective ADAS, or if you talk about low permeation hydrogen or even gasoline tanks for the matter of the fact, or EV charging. So for all these array of applications which are required, the new technology has to be there to make sure that the materials fit for the purpose to make it safer, lighter, more sustainable. Now a couple of examples I would put here. So this is one of the things, it's electric water pump which is made in PPS, polyphenylene sulfide, right? This is a material which is safer in a case of V0 as a flammability. This is already in BYD car, which gives good hydrolysis resistance, heat stabilization and good dimensional stability as well, right? Just I'll browse through a few of these applications, maybe some things will connect to you. Now talking about SHPT, right? So hydrogen fuel cells is something which we were talking about. Yeah, really nice new technology coming up. Several new things are coming up. The most important thing here is from our perspective or from the user perspective, from these materials, the ions leach out. They clog the filters, right? And then the efficiency goes down. That's where the lowest leaching of ions coming from these materials is the requirement for the industry right now. And this is where we have innovated. With this lowest ion leaching, the lifetime goes to 20,000 hours for these vehicles, for trucks and buses. At 20,000 hours into whatever mileage we can talk about, and these many kilometers these vehicles can run. Now, megawatt charging is coming, and there are many limitations as well, as the industry knows much better than I do. But one of the challenge which is there coming is comparative tracking index. That's the electric term, right? Now we talked about convergence of electrical industry and automotive industry. Electrical industry was always talking about this CTI, comparative tracking index of 400, 600 maximum. But when it comes to megawatt charging, that is not enough. We are talking about 600, 700, 900 volt CTI. Even there are no equipment to measure those. So that's where also we developed those equipments which can measure up to even 1500 volt. And we have these applications materials which go up to 900 volts. At the same time, these are, if you look at these materials, 0.4 to 0.2 mm V0 means very thin materials, 0.2 mm thickness, but these are safer because these are flame retardant. These are V0 at 0.2 mm. Somebody yesterday was asking me, do you have firewall? Do you have these materials which can stop flaming vehicles going on flames? Of course, it is because of thermal runaway and so many other things which are there. But when these materials are there, they will not add fuel because these are finally plastics. These will not add fuel, but this will try to extinguish that. Of course, there are charging guns, there are charging connectors, which need also these kind of safe materials where processability, low outgassing, and cost. Yeah, cost is also one of the most important thing. With the nice injection molding capabilities, at the same time good flow, these are the materials which will make the total cost quite low. At the same time, with full UL Underlighter laboratories and IUC regulations yellow card available, the time to market becomes really quick. So whatever materials which we are supporting or providing here from our basket, these have all these capabilities which will give us very short time to market. Same thing goes with, when we talk about the high voltage connectors, these are all orange connectors which we are aware of. That's where we have the solutions from all orange connectors. Again, the great thing which you see in the middle, that even at 125 degrees after 1000 hours, the CTI doesn't go down. Means even after your vehicle is on the road for longer time, with this aging which is happening because of the use of the vehicle, the electrical properties do not go down. So still your vehicle remains safer, right? Now, I mentioned about electromagnetic interference, EMI. That's where, of course, there are sources like inverters, DC motors, in-car and out-car radio frequencies, which are hampering the performance. And how that is hampering, I'll just show in a video here. I hope the sound is there. Sound, please.
Interference, also known as EMI. And EMI impacts the critical electronics that are needed to realize connected vehicles and autonomous driving. A proper shielding of emitters, such as high voltage components or radio frequency transmitters, is therefore needed to assure reliability during operation. At the same time, shielding of sensitive electronics, such as electronic control units, is needed as well. EMI shields made of conductive plastics offer many advantages over metal shields. They reduce weight, offer design flexibility, reduce processing steps, and reduce costs. Contact us via dsm.com/engineering materials to learn more about EMI shields made of conductive plastics.
Yeah, so that's plastics. When we talk about those are typically insulators, right? But then these are the conductive plastics which are getting best of both worlds and helping to shield EMI. Now talking about battery management systems, I'm not an expert in battery, but what we understood is, which I have highlighted here, that for battery to have the best performance, the ambient temperature range is from 20 degrees to 30 degrees Celsius. That's what we see here. And what happens below 20 degrees, the performance is reduced. After 30 degrees, the life is reduced. But why this is happening, which you see in the picture at the right top, that after 30 degrees, the reaction of the chemical reactions which are happening, those go exponentially high. And that's where the life is reduced. So what is required there? So there you need cooling, right? There you need active cooling as well as both passive cooling. And when you talk about active cooling systems, then there are coolants which are going in. And that's where in those applications you would need manifolds, cooling pipes, the connectors, flanges, all those things which need to be lightweight as well as safe. And what you need from the materials is very high chemical resistance. What you need is thermal resistance, easy processability. And that's what is not a new concept, because these are also some of the things which are used in IC, but same things are also required here. From our experience from IC can also bring it here, but passive cooling system, which I talked about, thermally conductive material and lower weight solutions are required. Those are the solutions which we bring onto the table. Now the third point is, second point is making it lighter. Of course, when the metals which are heavier, we want to bring it to lighter for the range. As I said, there are different applications. Wherever we see metal, we want to change into plastic. Yeah, and we have solutions for all metals, right? That's the beauty. If you talk about the composite structures like cross-car beam, yeah, we have also exhibited that in Auto Expo. The cross-car beam, I'll show also a picture in a minute, which could be easily lifted, which is hybrid material with plastics and aluminum. A great innovation. This is going to be also commercial quite soon. And there are several other applications like air springs, e-axles, etc., which we are supporting. Now, what happens is, with all those materials which we have, we can have the weight reduction versus metal up to 50%, not at the expense of cost. You can also have the cost reduction up to 20%. So these two things combined together, which you would see that the structural parts like front end module, e-motor mount, as well as cross-car beam, this is going to be launched in Daimler in 2023. So my colleague who has lifted this in two fingers, this cross-car beam, right? Very superior innovation. Also on hydrogen tank. So this is a hydrogen tank for commercial vehicle, which is 320 liter. So you can see the tall guy, but even this tank is even taller. And this is single. By the way, this is monolayer. So this is a polyamide 6 monolayer blow molded, where you don't need to have a 7 layer molded material, because it is giving best hydrogen barrier permeation, which is down to minus 60 degrees Celsius. Yeah? These kind of innovations which we are bringing into the market. Of course, there are also a lot of two-wheeler applications which we are serving, from e-motors to gears to charging plugs. Those are also there in our basket. The last part is about making these vehicles more sustainable. So from our own ambition, by 2030, we want to reduce our GHG emission and carbon footprint by 50%. Then 100% renewable electricity in all our factories. Net zero for scope 1, scope 2 by 2040. And last but the best part which we are offering to the industry is by 2030, we have around 1,000 products. For each and every product, we will have an alternative by 2030, which is either bio-based, recycle-based, or completely green material. And we are already halfway in 2023. That's the great thing which we are giving also to our customers. Of course, there are a lot of things which we can talk about, how these things are done, from the fossil oil gas, mixed plastic waste, from biomass, from mechanically recycled material. Actually, every year around 640,000 tons of fishing nets are dumped into oceans worldwide. 640,000 tons. What also we do here in India is we just take around 3,000 tons of fishing nets. Still, 3,000 tons of fishing nets out of these oceans. In India, we convert those into the materials which can be reused. And this is one of the examples where in Ford Bronco Sport, In 2022, the wiring harness was used with this material. It also received 2021 SP Innovation Award for first use of ocean plastic in vehicles. Of course, these applications, these materials are also available for all other EV applications as well. Now that's where we are your proven partner for any developments in automotive. We help with cost assessment, with materials, tooling, cycle times, reductions, etc. Different materials, I talked about some of the portfolio which we have. We can support with extensive portfolio, with computer-aided engineering, FME analysis, prototyping, part designing, and all across, because we are a global company. We have several locations, around 300, 350 scientists which are working on new technologies. That's where we bring innovation to our partners' table. Thanks for patience. Thank you.